sklearnmetricsexplained variance score. Description: explain in detail. The explained variance score measures the proportion of the variance in the target variable that is explained by the model's predictions. It quantifies how well a model can predict the target variable, taking into account the overall variability of the target variable. Higher values indicate a better fit of the model to the data, with a perfect fit corresponding to a score of 1. Inputs: Y true, the ground truth correct target values. It represents the actual values of the target variable. YPRED, the predicted target values from the model. It represents the model's estimations of the target variable. Explained variance, a float value between 0 and 1, representing the proportion of variance explained by the model. Steps: calculate the variance of the true target values. Calculate the variance of the difference between the true target values and the predicted values. Divide the variance of the difference by the variance of the true target values and subtract the result from 1. Metrics: explained variance. This metric measures the proportion of the variance in the target variable that is explained by the model's predictions. It quantifies the model's ability to capture the variability in the target variable. Visualization plots: scatter plot. A scatter plot of the true target values against the predicted values can be used to visualize the relationship between the two variables and assess the model's fit. Residual plot: a residual plot, true target values minus predicted values, can help identify patterns or systematic errors in the model's predictions. None. The explained variance score does not have any tunable parameters. Confidence intervals: confidence intervals for the explained variance score can be calculated using bootstrapping or other resampling techniques to assess the uncertainty in the estimated score. Challenge 1: if the model is underfitting the data, the explained variance score will be low, indicating that the model is not capturing enough of the variability in the target variable. Sample use case that resulted in Challenge 1: a linear regression model attempting to fit a nonlinear relationship between the features and target. Fixes to Challenge 1: consider using a more complex model, such as a polynomial regression or a decision tree, that can better capture the nonlinear patterns in the data. Challenge 2: if the model is overfitting the data, the explained variance score might be high on the training data but low on unseen data, indicating that the model is not generalizing well. Sample use case that resulted in Challenge 2: a complex model with many features trained on a small data set. Fixes to Challenge 2: use techniques like regularization to prevent overfitting. Consider reducing the complexity of the model by selecting fewer features or using a simpler model. Employ cross-validation to evaluate the model's performance on unseen data. Challenge 3: the explained variance score can be misleading if the target variable has a very small variance. In such cases, even a simple model might achieve a high explained variance score even if it does not capture the underlying relationships in the data effectively. Sample use case that resulted in Challenge 3: predicting a target variable with very little variation. For example, predicting the number of people in a room where the count is always between 10 and 15. Fixes to Challenge 3: consider using other metrics in addition to the explained variance score, such as the mean squared error or the R-squared score, to get a more comprehensive understanding of the model's performance.